Good morning everyone. Welcome to the session Machine Learning. I am Spandana, Assistant Professor, Department of CSIT from MLR Institute of Technology, Hyderabad. In the previous session, I had discussed about the introduction to machine learning and what are the types of machine learning, that is supervised, unsupervised and reinforcement learning with some real-time examples. In today's session, we are going to discuss that. The overview of today's session is, I am going to discuss what is supervised learning and what are types of supervised learning, that is about regression and the classification, and next difference between regression and classification, and next what are the real-time examples of regression and classification. After that I am going to give some quiz to test you, and what are the advantages and disadvantages of supervised machine learning, what are the applications of supervised learning, and lastly what are the list of algorithms that comes under regression and classification supervised learnings. Coming to supervised learning, what do you mean by supervised learning? I already told you in the previous session, let me discuss again. Supervised learning is a type of machine learning where an algorithm is trained on labeled data set. The labeled data set is nothing but which is having a predefined tags like name, type or number, which is going to predict the output based on a given input. The algorithm learns from the historical data where the correct answers are already provided by the human expert. So based on the previous data, it is going to predict the output of a particular input. That's why the supervised learning algorithms are trained using the labeled data set only. The goal of the supervised learning is to train the model which is going to predict the output whenever you given a new input. Based on that, it is going to predict the correct output. That is about supervised learning. That means here the training data set consists of input and also the output attributes. So here the input may be text data or a pixel of image or also audio frequency. The input may be text data or a pixel image or audio frequency, whatever it is. We are going to train the model with the help of these inputs. Once the model is trained, it is going to predict the output whenever you are going to give a new input. So that's how the machine is going to be trained using the labeled data set by using some supervised machine learning algorithms. Let me explain you with one example of supervised learning. As you can see in the image, the data which consists of images of an apple, this is nothing but it is a labeled data set. The training data set consists of a labeled data set of images of an apple. What we are going to do? We are going to use a machine learning algorithm and we are going to train the model. We are going to provide the labels and input to the model and we are going to give training to the model with the help of machine learning algorithm, and based on that, once the model is trained, then it is going to predict the whether it is an apple or not apple. We are going to give the training to the model like we are telling that if it is an apple, it is going to predict that is an apple. If not, it is not going to predict. Based on that, we are giving training. Once the model is trained, what we are doing? We are going to give a new input. As you can see in the image, we are giving an apple as an input to the model. So based on that, it is giving an output, predicting the output that yes, it is an apple. So that's how this is an output of a model. That's how we are going to give the training, and based on that, it is predicting the output of a particular input. Coming to types of supervised learning. So supervised learning can be further divided into two types. The first one is regression and second one is classification. Let me explain you in detail. Coming to regression. What do you mean by regression? Regression algorithms are used if there is a relationship between the input variable and the output variable. It should have some relation. It should work on two things, that is the input variable and the output variable. Regression means there are no labels. No labels are defined. Regression is about predicting a quantity or a continuous values, that is example salary, age, price. Coming to salary, you are going to predict the salary of a person based on his work experience. Next, age, you are going to predict the age of a person, it may be number. Next, you are going to predict the price of a particular product. Price is also number. That means regression is only going to work on a numbers. The output of a particular regression concept will be a number. Like I have explained you what is salary, what is age, what is price. It is going to predict the salary of a particular employee based on his work experience and also age of a particular person and price of a particular product. These all outputs will be only numbers. That's why the regression concept only works on numbers. Next, let me explain you regression with some example. Regression predicts the continuous values as an output. I already told you the output of a regression will be value. That means here price range. This image you can see the price range. It is going to predict the price of a particular thing like $200 or $500 or $1,000. This is number. Regression works only on numbers. That means the output will be only number. Next, coming to the numeric range. The numeric range of a particular thing may be, it is like numbers. It may be 1.5, 2.3, 6.8. It may be particular range of a particular thing. So this is also numbers. So regression works, the output will be only on numbers. Next, coming to quantity. For example, the quantity can be represented in 2 kg, 5 kg or 10 kg. That means this quantity also represented in numbers. So this is nothing but regression. The regression output will be only the number. It is a value. That's why we call it as a continuous value as an output of a regression type of problem. Next, let me explain you with one more. Regression algorithms are used to figure out connection between the dependent and independent variables. I already told you there is a relationship between dependent and independent variables. Here in the image you can see there is a humidity and the temperature. We are having two variables, that is humidity is an dependent variable and temperature is independent variable, where the temperature increases and humidity decreases. That means they are correlated. That means it is dependent and it is independent variable. It is going to work with input variable and output variable like that. Without one there is no other one. Like it means correlated. That means whenever the temperature increases and the humidity decreases, based upon a particular thing, other output is going to be predicted. Next, I explain you with one more example. As you can see in the image, we are going to train the model by using this temperature is one variable. We are going to predict the output rainfall in centimeter. That means we are going to train the model by providing the data to the model, like for this much amount of rainfall, we are giving some temperature value. For this much amount of value, this much amount of rainfall. For example, we are going to train the model by giving the data of a particular thing, like for this much temperature, this much amount of rainfall we are going to predict. So whenever the new input is given, like temperature is given to the data, then it is going to predict the rainfall in centimeter value. So it is also giving the output value. What I told you, regression output will be only in values. So that's how it is going to predict the rainfall in centimeter after giving the training to the model. Next, so that's all about regression. Next, coming to classification, this is one of the other supervised learning methodology. Classification algorithms are used when the output variable is categorical. Categorical is nothing but, which means that it consists of two classes. It may be yes or no, it may be male or female, it may be true or false. Categorical is nothing but it is having two classes. It may be yes or no, it may be male or female, it may be true or false. That means the output will be like yes or no in the classification type of supervised learning. Classification is about predicting a class or the discrete values. Classification contains labels like yes or no, like class A or class B, like that. The classification is having the output as a categorical, which consists of two classes like yes or no, male or female, true or false. That type of problems comes under classification. Next, with one more, classification algorithms works only on discrete values or classes or labels. As you can see, the classification type of problems will be yes or no, true or false, like 0 or 1, like that. Next, the classification is a process of categorization in which the new observations are recognized and separated. Here we are going to, I already told you, classification is like output will be yes or no, true or false, like that. So whenever we are giving some particular amount of data, like a mixed type of data, like labeled data set, we are going to give labeled data set to the machine learning model, and it is going to predict the output like as it is divided into class A, and it is one type of thing is divided into class B. That is two classes, class A and class B. That comes under classification. Next, one more example. As you can see in the image, it consists of different types of fruits, which is a labeled data set, like watermelon, strawberries and bananas. So what we are going to do, we are going to train our machine learning model with the help of supervised machine learning algorithm, like to detect, to divide the fruits into a particular categories, like bananas into one categories and strawberries into other categories and watermelon into other categories. That means it is like class A, it is like class B, it is like class C. That means it is going to divide different types of fruits, that is a labeled data set, and it is going to predict based on a particular type of a fruit. These are nothing but labels. In supervised learning, it is going to provide the labels also. This is about classification example. Next, one more example. As you can see in the image, it consists of apples, oranges and bananas. So what we are doing, we are going to give this data, feed the data to the model and giving training to the model with help of supervised machine learning algorithm. We are providing the labels and also the data to the model to predict whether it is an apple, orange or banana. So after giving training, then we are going to give some new inputs to the model. So whenever we have given the inputs to the model, then it is going to predict the output in a separate labels, like apples into one category, oranges into other category, and bananas into other category. These are nothing but labels, or also we can call it as classes. That is nothing but classification type of problem of supervised learning. Next, I think you have clearly understood what is classification and regression. Let me tell you the difference between classification and regression. In classification, we predict the class or label or type. Regression, I already told you, the output will be numbers. That means classification gives out discrete values like classes or labels. Regression output will be the values, that is continuous values. What we are doing in classification, we are going to give a group of data, and this method helps group the data into different groups. Just now I explained examples like apples, oranges, bananas into different groups. Next, regression. It uses the mapping function to map values to the continuous output, that is a number. Next, in classification, the nature of the predicted data is unordered. We have given the data as unordered. In regression, it is going to have ordered predicted data. That is the difference between classification and regression. I explain you with one example. In classification, will it be cold or hot tomorrow? That means whether it is hot or cold tomorrow. That means it is like the output will be like yes or no, true or false, like that. So the output will be either hot or either cold. That means it is going to predict the output like yes or no. That's how the classification comes under this type of problem. Next, in regression, what is the temperature going to be tomorrow? That means the exact value it is going to predict. It may be some number only. It may be some number only. That means the output of a regression will be number. So this type of problems comes under regression. Next, some of the real-time example of regression. Weather prediction. So as you can see in the image, we are having two variables, that is, one is temperature and one is humidity. So the temperature is independent variable and the humidity is dependent variable, for example. So what we are going to do, they are correlated. Correlated, like when the temperature increases, humidity decreases. So what we are going to do, we are going to train the model with the help of this data, like for this much amount of temperature, this much humidity. So based on that, we are going to give the training to the model of previous data. Then whenever the new input is given, like the temperature, some value, based on that temperature value, it is going to predict the humidity value. That's how it is known as weather prediction, which is example of regression. One more real-time example of regression, that is car price prediction. So here, for example, you are going to develop a machine learning model which is going to predict the price of a car by providing the details of a car specifications, and all the details of car is provided to the algorithm, and based on that it is going to predict the price of a car based on the car details. Next, other real-time example of regression is it is going to predict the share price. For example, you are going to develop a machine learning model for a particular company, for a particular company which is listed on a share market. So, here you are going to collect the previous data of previous shares and the previous data, and you are going to give the training to the model based on a previous data. Then the machine learning model is going to predict the share price of a particular company. Next, that's how about real-time examples of regression. Next, coming to real-time examples of classification. The first one is email spam detection. So, as you all know, nowadays we are getting some unreal messages like spam mails and genuine messages we get in our inbox. So, we need to track the spam mails. So, we are going to give the training to the model by using some filters of algorithms to predict whether the mail is spam or not spam. After giving the training to the model, then it is going to predict the mail as whether it is a spam mail or not a spam mail. This is known as email spam detection. Next, the other example is banking. So, in banking, we have to predict whether a customer is eligible for loan or not. Here what the bank is going to give the details of a customer, whether that customer is eligible for loan or not. So, after giving the details of customer and giving training to the algorithm, with the help of algorithm to the model, then the machine learning model is going to predict whether the customer is eligible for loan or not. Next real-time example of classification is, suppose the hospital has been providing the data of COVID patients. And the model is trained on a particular data, and based on that data you are going to train with the help of machine learning algorithm, and the model is trained. Then that model is going to predict whether a patient is survive or not based on a particular data which was given by the hospital. So, now I think it is clearly understood what is regression and what is classification type of supervised learning. Now, I am going to give you some quiz to test you. So, first quiz is that, suppose you have to develop a machine learning model which should predict whether Narendra Modi will win or not in 2024 based on a previous data. You have to tell me this type of problem comes under regression or classification. You have to mention the answer in the comment section. Next, let me give you one more quiz. For example, you have to develop a machine learning model with the help of all the house structure details provided. With that, you should predict the price of a house. That means this type of problem comes under regression or classification type of supervised learning. You have to answer this in the comment section. Next, what are the advantages of supervised learning? With the help of supervised learning, the model is going to predict the output of based on a previous data. That is one of the advantage. Here in supervised learning, we have an idea about the classes of objects already known to the human. Supervised learning model helps us to solve various real-world problems such as fraud detection to identify the frauds and the spam filtering to identify whether the mail is spam or not spam. Next, coming to the disadvantages of supervised learning. Supervised learning models are not suitable for handling complex tasks. It is only going to solve some simpler tasks. Supervised learning cannot predict the correct output. Why it is not going to predict the correct output means, whenever you are giving the test data different from training data set. So whatever the training data set you are giving training to the model, you have to give input from the training data set. If you are going to give the input different from the training data set, then it is going to predict the wrong output. So that is one of the disadvantage. And here the training requires a lot of time is required here. That's how one of the disadvantage. In supervised learning, we need enough knowledge about the classes of object. That are the disadvantages of supervised learning. And let me tell you the applications of supervised learning. So it is bioinformatics is one of the most popular supervised learning application. Nowadays, most of us are going to use in our daily lives, in our mobile phones. For example, here the bioinformatics model is going to collect the information. It is going to preserve the information of fingerprints or iris texture, earlobe, etc. It is going to collect those data, then the machine is going to train that model, then it is going to predict that our iris fingerprint, and based on that the mobile is opened. So nowadays every mobile is very smart enough to identify the biometric or fingerprint, and based on that your mobile phone is opening, right? So it is going to provide a system security, as every mobile needs the security. So this is one of the supervised learning model application. Next other example is speech recognition. It is also one of the application of supervised learning. Like Alexa, Google Assistant have become an integral part of our families. Like whenever you open Alexa and asking it to play a song for you, it is trained on a human voice only. These both models are trained on human voice. Based on that, it is going to predict the output. For example, you open Alexa and play a song for you. You ask a song, then it is going to play a song for you. Next, whenever you open Google Assistant and asking to make a call to Sam from your contact list, then it is going to make a call automatically from your contact list. So that's how which has become an integral part of our families, which is working on our voice only. Next, one more application of supervised learning is spam detection. As I already told you, this model is going to be trained by filters of algorithms to detect whether the mail is spam or not, whether it is spam mail or not. Automatically it is going to delete the spam mails, and it is going to detect whether that is a spam mail or not spam mail, and the real messages are going to be stored in our inbox, and spam messages are automatically deleted after a few minutes or one day, like that. And the other application of supervised learning is object detection. Here we need to define something, that we need to use this software. For example, you have given a huge amount of data set to the model and giving training to the model to detect a particular object, or a object is recognized. For example, as you can see in the image, it is going to predict that is a dog image, and another also dog image, and another is a cat image. That means it is going to detect the objects. We are going to use Raspberry Pi algorithms to detect the objects, and this is also used in self-driving cars, because in the self-driving cars you need to detect the objects like who are walking on the road or any nearby vehicles. So for that purpose, this object detection is one of the application of supervised learning is used. Next, list of algorithms that comes under regression supervised learning are linear regression, polynomial regression, regression trees, and one of the other thing is classification type of supervised learning. The algorithms comes under classification supervised learning is logistic regression, support vector machines, naive Bayes, decision tree classification, random forest classification, k-nearest neighbor classification. These are the algorithms comes under regression supervised learning and classification supervised learning. These algorithms are going to be discussed in the later coming sessions. The summary of today's session is, we have discussed that what is supervised learning. It is going to be worked on a labeled data set which is going to predict the output based on a given input. And also I have explained you what are the types of learning. What is regression? The output will be number. What is classification? The output will be labels or classes like yes or no, true or false, like that. And I have explained you the difference between regression and classification with some examples and the real-time examples of regression and classification. And I have given you some quiz to test you which type of the particular type of problems comes under regression or classification. You need to mention the answer in the comment section. And what are the advantages and disadvantages of supervised learning? Like advantages, it is we are going to use labeled data set. So based on that, it is going to predict the output. Disadvantages is it is taking more time. Training time is more. And the applications of supervised learning, it is going to detect the spam detection and also the object detection, so on. And also I have explained you what are the algorithms comes under regression type of supervised learning, classification type of supervised learning. So that's all we discussed in today's session. In the next coming session, I am going to come up with unsupervised learning and the types of unsupervised learning. Thank you.